Hello and welcome to your Project 8 video. This is the one that uses string parsing and string functions to, manipulate strings, pull things out, update things. And as usual, we'll be going from a string into some integers and then back to strings and that kind of stuff. So, all right, if you look on page 497, you'll see an example of the form Meriwether credit. The user enters a credit card number consisting of 5 digits. Then through some mathematics, very simple stuff, you're going to check, verify that is a valid number. And you'll see in step 8-42, you'll see the entire algorithm. Now, you probably ought to have the book open while you're watching this. The only thing you might not have seen before, if you go to the form, they tell you in the description that you need to make the verify button the default button. And what that means is when they hit the enter key, it will fire that click event. And as you can see, if you click on the form and go to the properties, you can see accept button. That's that property. So I'm basically just clicked on the list, and you could have done it with the exit button, which is not good practice, obviously. But every time the user hits the enter key, then it ends the program. That's not exactly what you want to do. All right, so I'm going to try a little different approach on this particular video so as not to make it so long. I'm going to pause the video. That's my want. I hope I can do it without messing it up, and just copy and paste the code in the relative sections or relevant sections because I've already written it and tested it. So, all right, let's go to the code. All right, you got your verify click and of course your exit button. Now, I'm doing a shortcut here just because the main emphasis here is not on validating data as much as string processing. So I'm kind of short-circuiting what I would normally ask you to do here. But here are all of our variables that I need, and I thought I needed. I have the string variable, or a variable of type string that holds all 5 digits. So what happens is the user enters a 5-digit credit card number. You'll take each one of those digits, which is of type string because the .text property of a text box is of type string, and you'll have to strip them out and then convert them to an integer and place them in some other variable. So that's what I've done, so we can do the math on them. And as you can see here, this is all 5 digits. This is a temporary working variable, and you'll see why I have that later. And I've got some integers here. I've got digit 1, digit 2, digit 3, digit 4, and then the 5th digit is the original check digit. And then there's a calculated check digit, right? And then at the end, we're going to compare one to the other, and if they're the same, it's a valid digit. If they're not, it's an invalid credit card number. I meant to say credit card number. All right. Now, the way I'm getting around some of this validation here is I'm using the like operator in an if statement. And so what it does is it compares this filter over here to what's in this string variable, and if they are the same, that means there's 5 digits in there. Now, this is not foolproof. I mean, you could put 5 alphanumeric characters in there and it might blow the program up. I'm not really worried about that right now. Okay. But essentially, if they've done less than 5 or more than 5, then it comes down here and just throws a generic message. And you can limit the number of characters, max number, I believe it is, on this text box. And I think I've got mine set to max length is set to 5. So they can only put 5 characters in there, but it's not really necessary with that if statement. Okay, just a little extra information. So what I did is I went through figure 8-42 and I put comments in there to sort of match what they're showing you here. Okay, so the first thing we do outside of that if is we go ahead and grab that text, whatever they put in there, hopefully 5 digits. In some type string, we put it in our string, and then we're going to use that to set up our if. So if it is 5 digits, then the first comment says convert digits to integers and place into the digit variables. Okay. Now this is where some of the string processing comes in. So, okay, there's the code for this. What I'm doing is, we've got all 5 string digits in here. I want to convert those to numbers and then put them in these integers variables over here so that I can do math on them. So I've got string 5 digits dot substring. Substring, if you remember from the working through the text, it grabs a smaller string out of a larger string. In this case, I only want 1 character. So, and remember that when you're talking about strings and later on arrays, when you're talking about the first character in a string, it's at position, or they also call it index 0. You start at 0, not 1, okay? So I'm telling you here to start at the first position, which is index 0, and grab one character. And then I'm telling it to start at the second position, or index 2, and grab one character. So I'm going from 0 to 3, which is 4 digits, because 0 is a number. That's 1, 2, 3, 4. Grabbing one character at the time, converting it to an integer, and sticking it in its associated integer variable. And then the last digit, the 5th digit, which is at position or index 4, is my check digit. That's the original check digit. So once I do this, then I have everything in integers that I need in order to continue on with the math. So let's continue. Okay, so the next step is multiply the 2nd and 4th digits by 2. And I've got a typo here in my comment. All right, so we did that right here. All I'm doing is I'm pulling out of memory, multiplying it by 2, and overriding it over itself. So now I have a new digit 2 and a new digit 4 that have both been multiplied by 2 per the instructions. And you can see most of this stuff in 8-42 if you want to follow along. I'd suggest it. Okay, so the next comment says, check if multiplication above results in any 2-digit numbers. If so, add each digit together and overwrite the 2nd and or the 4th digit. All right, now if you look at 8-42 in the book and look at step 1 down here, it says multiply the 2nd and 4th digits by 2. All right, so 8 times 2 gives us the result, see the result arrow, of 16. That's a 2-digit number. However, if you look at the 4th digit in this scenario, 3 times 2 is 6. That's not a 2-digit number. It's a single-digit number. Well, how do you deduce that? Well, we got them in integer form, so you just compare them and see if they're greater than 9. If they're greater than 9, then obviously it's a 2-digit number. 10 is a 2-digit number, 11, 12, and so forth. So I'm checking the 2nd and the 4th to see if they're greater than 9. If they are greater than 9, that's a 2-digit number. So what I'm doing is I'm converting this 2-digit number into a string and putting it in this temporary working variable that I talked about up here, right? And then I'm going to add those two together. Well, I've got to take those string characters at position 0, right, and index 0 and index 1. I'm grabbing one character, converting them to an integer using the parse method. You could use convert to, I suppose. I'm adding those two integers together and overriding it into that particular digit, which is, as you'll see here, is what they did. Step 2, if necessary, add both digits together. Well, you add 1 and 6 together to get 7, and then you overwrite that in the original number. So we're talking about int digit 2 and int digit 4. All right, same thing here. I've got string 2 digits, grabbing that. It's only if it's greater than 9. And then I'm adding them together and updating int digit 4, okay? Okay, the next step is to add all 4 digits together if you're following along in figure 8-42, right? So that's what I did. Digit 1, digit 2, digit 3, and digit 4. And here's my sum variable, int sum of the 4 digits. The next instruction here says divide by 10 and get the remainder. If the remainder is 0, then the check digit is 0, else subtract the remainder from 10. This is the check digit, all right? So let's look at the code for that. Okay, so how do we get a remainder of a division? We use the modulus operator, the mod keyword. So I'm taking the sum of these 4 digits that I got up above here and dividing by 10 and storing the remainder in an integer variable called int remainder, all right? Then I'm looking at the remainder to see if it's greater than 0. If it is, then I got to subtract the remainder from 10. That's my calculated digit. That's my new calculated digit. Remember, we had the original digit up here that the user entered, and this is our calculated check digit. Otherwise, it's 0, okay? Now, the next step says, and this is probably the final step, compare the original check digit to the calculated check digit. If they are equal, display a valid message, else display an invalid message. Okay, there's the code for that. So we're looking at comparing the original check digit to the calculated check digit. If they're equal, then it's a valid number. And I display that in the label output, card status text. Else, it's an invalid number. So let's run through some examples using the one that they gave us in the book, and then a couple of others. All right. Save this. F5. Okay, so the first number, and you can see focus is in the text box as it should be. The first number is 18531, 1 being the check digit. All right. Click verify. It says the credit card number is valid. All right, notice how it has selected everything up here. If I come back here and put in 12, it's going to pop up and tell me that I need to enter a 5-digit number. Right? Well, I have it limited to I can't put any more than 5 digits in there because I set the property at design time, so I got to worry about that. So let's do another number. Let's do 21062. All right. Now notice that verify is the default, so if I hit enter, it's going to go ahead and run it as if I clicked it. This credit card number is invalid. All right, let's put another one in. 18641. That one's invalid as well. Let's go back to the original. 185, oops, what was it? 31. All right. So that is a valid number. Now, I encourage you to set breakpoints in here and show and just add all these to your watch window, because you may want to look and see how this works, or you may get some errors when you're typing it in because it's kind of tedious. Let's run it. Let's see. 8531. All right, so there's my breakpoint. I press F10. I start stepping through here. As you can see down here in my watch window, these numbers are coming up, and I can tell what they look like and if they're what they should be. And there's my number. The string says 18531. If you look at all those digit numbers, including the original check digit, it's 18531, which is what it should be. All right, so now we're going to multiply them by 2. Digit 2 becomes 16, which is what it is in the book. F10, digit 4 becomes 6, which is not a 2-digit number, right? So we're going to add all those together. That one is a 2-digit number. That one is not. So that skips that. Sum of all 4 digits is this. Okay. Let me scroll down a bit here where you can see what's going on. So I added them all together. Now I'm checking the remainder because I did a division right here, right? Modulus. Let's see what my remainder is. My remainder is 0. All right. So if it's greater than 0, then that's what the check digit is. Otherwise, if it's 0, then that's what it is. It's 0. It was already set at 0, but I just did that to be safe. So here's my final comparison. If the original check digit equals the calculated check digit, we have a valid number, and it outputs that message. Otherwise, it's invalid. And then I select all and set the focus back. Okay. Now that's it. So good luck, and hopefully this is not a super long video, and hopefully this method works okay. We hope it does. And I will see you next video.